Okay, so we did some keying earlier a few months back, and I thought it might be appropriate to do to walk a Grimmia through the keys because they're another genus that tend to be kind of difficult for various reasons, and I got interested in them and started trying to write a key for Arizona Grimmia, and one of the results of that is you have to listen to this tonight. So the how do I change slides? Ah, there we go. Um, the one we're walking through the keys tonight is Grimmia longirostrus. And I'm sometimes when people are taking you through keys, they kind of hide from you where it's going, and other people decide to show you what it is in the beginning. I'm going to show you at the beginning so you kind of know what you're looking for. So that big red arrow there is going to indicate when you're looking at a part that belongs to a Grimmia longirostrus. And here's just kind of a grouping of some of the diagnostic features of the species. And so if you go to your big green book, the Flora Neomexicana 4 on page 183, the family Grimmiaceae has a key to genera, and it starts like this. And I want to start here because uh, Grimmia, well, because all Grimmia look alike if they're in the family. I mean, at a glance anyway. So let's just go through some. Let's get down to Grimmia first and make sure we're working with a Grimmia. So the first step in the key to genera is this number one up at the top there in the red triangle rectangle. Plants Cladocarpus. We haven't talked about that yet, so I guess we'll talk about it now. The sporophytes are rising from the tips of branches. Does that sound familiar? Rather than from the tips of main stems. Okay. And so if you go to number two there, under the first lead one, go to number two right under it, laminal cells strongly papillose. And that's Niphotricum or Niphotricum, however you want to say it. Uh, and I think this is great because this one doesn't really look like a Grimmia. I mean, it is really papillose. It just looks like it has warts all over it, whether you're looking at the lamina face on or whether you're looking at a cross section. So what's that other lead look like? It looks like this: laminal cells smooth or appearing weakly papillose by the strong sinuous cells. Um, and if you look at those cells, those cells look like worms crawling up and down the leaf. And this particular one has really thick walls. The walls of the cell are about as thick as the lumen of the cell, which is the part of the cell that isn't a wall. And and it looks, if I just look at that myself, I say that really looks like a Grimmia. If I didn't have that cladocarpus look to it, which we'll talk about in a moment, I could look at the cross section and see, you can see those really thick walls in the cross section. That's pretty unusual, even for a thick-walled Grimmia or a thick-walled Schistidium, which are Schistidium is another genera in the same family. So let's go to the next number one. This, remember, we're still on the key to genera on page 183 up at the top. And the other choice is that the plants are acrocarpous. The sporophytes are rising from the tips of the main stems rather than from the tips of the branches. I'm going to back up because I think I forgot to talk about cladocarpus. Um, yeah, I did. I'm sorry. So down here on the right-hand side is this condition called cladocarpus. It looks like an acrocarp, doesn't branch or doesn't branch much. And but the exception here is that if I hope you can see my mouse, the sporophytes coming off a little branch over here on the side, just some this kind of little adjunct branch like you see on a pleurocarp, except these guys rise up like acrocarps. That's a cladocarpus moss. So back to acrocarpus, which we're now contrasting with cladocarpus instead of pleurocarpus. Um, and we want to look at the first example of that. So sporophytes are rising from the tips of the main stems. You've just been through that, so I won't spend a lot of time on it. But there's the big red arrows that indicate that you're looking at two examples of Grimmia longirostris. The white arrows are to show you where the setae are. One white arrow is pointing at an actual capsule. On the left there, it looks like the capsules have broken off, but you can, just to give you a clue what that would look like under a microscope, you'd see those seta coming out of there, and on the right there, you can see that there's a capsule and seta coming out of that. From that number one, we move down to the leads three. The first one goes to schistidium. If you look down there on the right-hand side of the lower right-hand side of the red box, columella usually attached to the operculum and deciduous with it. Calyptra small, covering only the operculum mitrate. I'm sorry, covering only the operculum mitrate. And then he explains what that means, or cuculate explains what that means. We're going to look at it, so let's just get on with it. Um, so there's examples of schistidium that are mentioned in the key. The capsules are immersed to emergent. So immersed means they're just buried down in the leaves and really hard to see. Emergent might be this one over here where it's kind of I know that's not actually emergent. It just looks like it's emergent because the leaves have been broken off, but they could come out a little bit in a schistidium. Now, I think just about every one of these here is probably fertile, but you can't tell because they're buried in the leaves. So these where you see the leaves spreading a little bit, here, 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 and here. Those definitely have capsules in them. What does the operculum falling with the columella attached mean? Well, there's a picture of it. The operculum is that little cap on the capsule just before it's ready to turn loose of all its mature spores. And the columella, which is usually covered with spores, is attached to it. You'll almost never see that. I don't even remember. I think, I mean, if you look at this over here, this capsule on the left, and you'll see that a lot of these capsules are already mature and have broken open. That one's about to. If you put that one in the water, it might break open and turn loose of its operculum and columella together, but I doubt it. A better way to tell is the capsule itself, because it says this really short seta. I mean, that you can't tell it's the whole thing because it broke off, but that is the whole seta. It's shorter than the capsule, and it's straight, and it's centrally attached. That's your best bet for telling a schistidium when you're in the family Grimmiaceae. Calyptra, I think Kelly showed us one, didn't he? Or somebody did. And this one is mitrate, which means it has several lobes down at the bottom. So there's a lobe, there's another lobe, there's another lobe, there's another lobe. Um, doesn't have to have that many lobes, but this one is lobed. The other lead number three, is columella not attached to the operculum. The calyptra small to large, mitrate, cuculate, erose, smooth, or plicate. Just in other words, kind of a potluck there. Capsule exserted, occasionally immersed, seta straight, sigmoid, or arcuate. We'll talk about that too. Leaf margins plain, recurved, or incurved. So here we are. These are all Grimmia. The one with the big red arrow is our target, Grimmia longirostris. Just one little digression here. This rostrum on the operculum is the reason it's called longirostris. Longirostris doesn't always have a long rostris, but there it is. This one does. Uh, and you can see on this one the capsule's exserted. There are leaves down there below, but this is sticking out clear past them, and the seta is straight. Over here we have one of those that's immersed, and the reason you're seeing it is because the leaves have all been broken away so that the capsule can be observed. Um, it has a very short seta, like I was telling you earlier, just like in the schistidium, but this one um, is called sometimes it's called sigmoid. And here, this one's almost sigmoid. It's a little off center. You can see this capsule has a belly on it over here, and the attachment is a little off center, and then it kind of curves a little bit, and then it goes back in here. So in a really in some cases, that gets to be kind of exaggerated and actually forms an S curve, which is why they call it sigmoid. Again, the capsule, this one has a mitrate capsule, calyptra. You can see one of these lobes on edge, and then this much bigger lobe here and another big lobe there. So I got to back up here and remind myself where I am. Um, I want to go to this. We showed you what a Grimmia looks like back here, but I want to cover these other possibilities because if I don't cover them, you'll kind of wonder, well, like, well, what do those look like? So let's just look at them and see what they look like. In Cosynodon, the first one, the calyptra is large, covering at least half the length of the capsule, campanulate mitrate, plicate, awns on distal leaves typically longer than the blades. Um, Stem leaves lanceolate to ovate. Um, well, I'm skipping down. Yeah. So then we go down to stem leaves, lanceolate to ovate, keeled distally, plicate or not, distal blades 1 to 2 stratos, plants olivaceous to blackish green, acidophilic, meaning it grows on granite and volcanic rock and stuff like that. So, and then the other one, the other choice, because I'm going to show them to you both on one slide, is the stem leaves are ovate to obovate, concave or only somewhat keeled, distally, not plicate, distal blades 1 stratos, plants yellow-green to dark olivaceous, calcilophilic, meaning it's found on things like limestone, sandstone, and what geologists call basic rock, and that's Jephthyobrium. So here they are, so you can see them. Uh, This says Cassinodon and one Grimmia because about 4 or 5 years ago, uh, the Ignatov, I think it was Michael Ignatov or somebody moved uh, Cassinodon calyptratus to Grimmia calyptrata. And so Grimmia calyptrata, that could very well, I don't remember what this one is, but that could very well be Grimmia calyptrata there. But you see the uh, the calyptra comes all the way down, covers the capsule entirely. Um, and over here, and oh yeah, here's the plicate. Here's the capsules without the calyptra on them. You can see a fresh calyptra down here, but here's these plicate calyptra they're talking about. So that's Cassinodon, which will probably all become Grimmia in the next 4 or 5 years when somebody gets around to doing the genetic work. On the right here is however you say it, Jephthyobrium. Um, and there's 2 species in that, but they tend to have really broad leaves. Like this one's exceptionally broad leaf, and then here's another example of that leaf. And this this right here in the bottom right hand corner, that calyptra is a little bit beat up, but you can see it comes if you look at the side here where you can see a silhouette of it, you can see it comes all the way down to there and all the way down to there. And maybe this may be calyptra as well. So a lot of that's covered with calyptra. So that's what you're going to miss by not doing those. Let's go back to Grimmia longirostris and see if we can get to that. Um, so we're going now to page 190. Kelly has 2 keys in the big green book for Grimiaceae. One of them is a key to all species. I'm jumping to the Grimmia key because there's because I can. That's why. Um, and so we're on page 190 in the Grimmia key, and we're going to look at these 2 leads. The seta attached number 1, seta attached eccentrically to the capsule base, capsule immersed, smooth, swollen on one side, versus The other number one at the bottom, CETA attached centrally to the capsule base, capsule immersed to exserted, smooth to plicate, not swollen on one side. So you already saw these really. There's the immersed capsule with that semi-sigmoid, very, very short CETA. And as I said, that capsule would be completely immersed, except that the leaves have been broken away to show you the rest of it, the capsule and the CETA. And on the right is, again, the big red arrow. This is a Grimmia longirostrus. It has a capsule with a straight CETA centrally attached. Um, you can kind of see that that's symmetrical across there. And over here, you've got that big belly I pointed out earlier. And remember, this big belly in the off center, that sets it apart from schistidium. Otherwise, those two are virtually indistinguishable. That takes us to, because we're here on the big red arrow, that actually took us to lead number 5. Uh, so at the top, leaves, again, we'll do both of them on one slide in a moment, but I want to show you the key first. Leaves merely one stratos distally, the margins that most narrowly two stratos with one or both margins recurved. The other number 5 at the bottom is leaves 2 to 3 stratos distally, or one stratos with the distal margins widely two stratos. Uh, I must have cut something off there. I apologize. But we'll take a look at it and then you'll understand what I'm talking about. Um, leaves merely one stratos distally, the margins at most two stratos with one or both margins recurved on the left there. So you can see this is all from here to here is all one stratos. And just at the very end, it's two stratos. Same on this side. Over here, again, the big red arrow, that's Grimmia longirostrus. There's a little bit of one stratos here and a little bit there, maybe right here, but there's a lot of two stratos in here. In fact, you would just call that something that's broadly two stratos at the margins if you want. That took us to lead 10. Um, leaves leaves concave, costa not prominent, margins plain or incurved, plants dioicous. I'm not going to talk about dioicous because it's very difficult to prove, and I don't think you need it with Grimmia. Um, 10, the other 10 at the bottom, leaves are keeled, costa prominent, margins recurved, plain or incurved, plants autoicous or dioicous. Again, I won't talk about that. But again, we have the Grimmia longirostrus on the right, the very same cross section you saw earlier. This is a keeled leaf because it looks like the keel of a boat. If you turn that 90 degrees to the right, this would be the bottom of the keel, and these would be the gunnels on the boat. Over here is the concave leaf, and you can see there's in this particular, of course, I picked this picture, right? But still, there isn't a hint of any recurvature at the tip like there is here. You can see this one just tilts out a little right at the tip. This one doesn't really, but it also does not curve in like this one. So this one on the left is Grimmia ovalis, and that's our Grimmia longirostrus. That takes us to number 12. So we talk about the margins plain or incurved. Margins plain recurved on one or both sides, at least in the lower half of the blade. And that looks like this. You've seen them already. Margins recurved on one or both sides, at least in the lower half of the blade. So I stuck in another cross section here so you can see, excuse me, that this is actually really recurved. This one hints at it, and so does this one over here. But here, these are definitely kind of curved inward. I think the lesson to get from this is that you need to look at more than one cross section. And if you're cutting cross sections to look at under a microscope, you're going to have more than one. Try to get them from, sorry, try to get them from lower down in the leaf. Uh, and some in the middle, and maybe some at the tip. So this is closer to the tip. This is lower down in the leaf. And you can see the recurve here in this shot. It's that black line where it folds over and turns out. And then again there. Uh, oh, I see. Okay. And that took us to 17. And below 17 is the number 23. The first one is basal juxtacostal cells straight, thin-walled, distal juxtacostal cells one stratos, the cells often bulging. Plants small, less than 1 centimeter long, blackish, moist alpine habitats. So this is not Grimmia longirostris, but I just want to show you what it looks like so we know what we're talking about. Here's the straight uh, Here's the straight basal juxtacostal cells along here. Here's the costa. Juxtacostal is right next to it. They don't look particularly thin-walled to me. I'm not sure if it could be because I'm shooting multiple exposures at different focuses, and what you may be seeing is a thin wall that's tipped sideways, and by the time you get the whole thing in focus, it may make it look thick. Um, but they are straight, okay? And here's a picture of the habit of the plant. And over here is that he talks about the one stratos uh, right there, down by the costa, and one right there. And in fact, I think this is one stratos here with a little bit of gunk between the lamina and the costa. We don't. I don't know. I guess you have Cesitana in New Mexico. I don't think we have that in Arizona. Might have it in Colorado. I don't know. But there it is in case you have to worry about it. And and here we are where we're talking about the other 23 basal juxtacostal cells sinuous, thick-walled. Uh, and by sinuous, let's see, here's the juxtacostal cells. These aren't particularly sinuous. They're a little bit wavy, but they are thick-walled. You can see some really thick walls in there. So you have to remember that keys have to talk in generalities. And the plant you're looking at doesn't live in generalities. It's just what it is. Cells not bulging, plants robust, greater than 1 centimeter long, yellow green to very dark olivaceous. That yellow green does not mean the color here. This is an artificial color from a stain I used on the slide. But but you can see that it's all two stratos. And these are both Grimmia longirostris, by the way. So I think we're almost there. Uh, Leaf margins, two stratos, not thickened, stem central strand present, the epidermis thin, versus number 24 down below in the red box, leaf margins multistratos and thickened, stem central strand absent, the epidermis thick. What does that look like? Looks like this. Leaf margins, two stratos, not thickened. Um, by not thickened, it means there's no club on the end of this. That looks like a beginning of a club there, but I don't think that really counts. Um, so it's just two cells across. And over here is a cross section of a stem. These are always a little hard to interpret. I don't know how well you can see it on your screen, but on mine, there's the central strand. And I can actually see the walls of the little thin cells that make up the conducting tissue in there. They're I don't know if you can see them, but when you see that all these cells suddenly just kind of disappear and there's this hole maybe a darker color in the middle, that's usually a central strand. Again, both those shots are from Grimmia longirostris. And the other side of that was just again, I want you to see the other side, the flip side of the lead. The leaf margins multistratos, thickened, stem central strand absent, the epidermis thick. So here's the thickened margins. They're definitely thicker than the rest of the lamina. And then the stem central strand absent, so that you have these great big cells, and you can see that the walls all attach. There's no vacancy or small cell, thin wall cells in there, like we saw in the last one. The uh, the epidermis is really thick here versus much thinner here. That's not probably better to have had them side by side, but I think if I go back down real quick, you'll see that there's a big difference in how thick these are versus how thick those are. And then the last lead was under that 24 leaf margins, two stratos not thickened, was the plant's autoicus. Uh, Again, with Grimmia, you probably don't have to worry about that. This is what you have to worry about with Grimmia longirostris. The costa transverse section is like um, you can almost identify this plant from one good leaf cross section and a picture of the leaf because the cross section is kind of it's pretty different by the time you get down to this part of the key. You can see this. They call this a uh, reniform costa. That would be reniform. That would be reniform. It's a little harder to tell. So this is on the left-hand side here. I'm down lower in the leaf, but the catch is that there's one, two, three, four, five, six guide cells there. Other Grimmia usually have like two or three, um, and they go down to as little as three guide cells up in the upper parts of the leaf, the distal parts of the leaf. One, two, three, one, two, three. And again down here at the base of the leaf, one, two, three, four, five, six. I don't know how many, but that's probably the main key to Grimmia longirostris is that cross section right there. And again, I've inserted because it's in the key the business of the cross section of the stem, and you can kind of just see that central strand is just kind of a dark area there. But there are cell walls in there. That's all, folks. Any questions?
Yeah, I had a question. Uh,
Go.
I wonder if you would explain some more what it meant to be for the Costa to be reniform, and if you had any comparisons with something that wasn't reniform.
Oh, I should have put those in here. Are you seeing this slide with Grimmia latior on it?
Right.
That's not a reniform costa. That's a winged costa. This over here is a costa right here. That is not a reniform costa. This is a pretty ordinary Grimmia costa right here. Even though it's kind of an unusual Grimmia, the costa is pretty ordinary. Does that help any?
Sure, yes.
I can also, if you want to email me, I think somewhere I have a whole paper on the cross sections of Grimmia costas. It's pretty interesting. I think you'd like it.
Rice, I had a
Yeah,
question about, I got a little confused in terms of the capsule and the attachments so Schistidium always has a central attachment of the seta to the capsule, and Grimmia can either be central or eccentric. Is that right?
that is correct.
Okay.
The ones that will be eccentric are the ones that are immersed. So there's not a lot of them to worry about. But when you find immersed capsules and you think you have something in Gurmiaceae, the first thing you want to do is separate the schistidium from the Grimmia. And if it's centrally attached, it's schistidium. If it's eccentrically attached, then it's Grimmia. Also,
Okay.
the eccentrically attached is on a lopsided capsule with a big pot belly on it. What do they call that? I can't remember the term for it.
Strumos, maybe.
Yeah, strumose. Yeah, thank you.
Yeah. Yeah. And then,
Anybody
uh,
else?
one other quick question that you showed towards the beginning, you showed that one with the really the sinuous cell walls.
Oh yeah, the used to be called racemitrium, and now it's
Ah,
Bucklandiella.
I was going to say that looks like a racometrium to me, but that's a segregate from racometrium, huh?
I think yeah, I don't know the complete answer to that. I think a lot of stuff was moved. A lot of stuff in racemitrium was moved to Bucklandiella. They still call it racemitrium in Europe, I think.
Yeah, I think it was Xander that worked on those, didn't he? I think he was. They made all those changes.
Oh, yeah. I don't.
I think it was.
I probably have the paper and don't remember.
Yeah, because he gave a workshop in Oregon about these. Remember, I'm pretty sure it was him.
I can't remember if I mentioned this or not, but you see these sigmoid walls you see them in Grimmia also. But boy, these are really exaggerated. I mean, and there's lots of them, and they go way up the leaf. Uh, but if there's a doubt, like I said, you go to this cross section here, and you can see that 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 that's a funny looking cross section for a Grimmia. I mean, that's kind of rectangular and really thick walled cells. You don't really see them quite like that in Grimmia or Schistidium. I guess you might actually have to worry about that in California, huh?
Mhm.
Are there any more questions?